Paint booklet, all calculations, section 8, electricity. These are high demand questions, and we're going to do 10, 11, 12 and 13 here. So I'll put my little bug FIFA up there just to remind me of our preferred method. So what is the potential difference across the bulb of a 5.5 ohm which has 5.5 ohm resistance and a charge of 200 coulombs flowing for 2 minutes? Okay, give you answer two significant figures, usually 1 mark kicking around for this. So potential difference across the bulb, V. Okay, so know what that is. It's got a bulb of 5.5 ohms, so R is equal to 5.5 ohms, and it's a charge of 200, so it's a charge of 200, so Q is equal to 200 coulombs, and it's flowing for 2 minutes, so 2 minutes, so T is equal to 2 minutes, which is equal to 120 seconds. Now I need to find voltage. So these are the variables I've got: resistance, Q and T. Now I know that V is equal to IR. I've got resistance but I haven't got current, but I do know that Q is equal to IT, brings in 2 2's. If I rearrange that, okay, that will give me I. So let's just put some numbers in. 200 is equal to I times T, which is 120. We'll make I the subject, so I'm going to take I to the other side. So divide both sides by 120. It will cancel on the right hand side, and that'll give me 200 divided by 120 is equal to I, which is equal to 1.6. 1.6 amps. Now I know that V is equal to IR, so current is 1.6, resistance from up there is 5.5, so that now equals 9.16. So 1.6 times 5.5 is equal to 8.8. I thought I'd double check that. Sorry, I thought I'd double check that. 8.8. Now let me triple check that. 1.6 times 5.5 equals 8.8 for sure. So it needs to be two significant figures, which it already is. So my answer is 8.8 volts. Right, number 11. The series circuit contains a bulb and a fixed resistor. So the charge flowing through the bulb is 300 coulombs and the energy transferred across it is 900 joules, and the battery supply in the circuit is 9 volts. So I've got a series circuit containing a bulb and a fixed resistor. So there's my battery, 9 volts, and I've got a filament bulb and a fixed value resistor, so that's 9 volts. I've got it doesn't tell me anything. It tells me I've got 9 volts here. It doesn't tell me anything about the resistance of these two devices, but I do know that I've got a charge flowing through the bulb is 300. 300 coulombs, and I do know that we've got the energy transferred across it is 900 joules, so E is equal to 900 joules. Okay, so what is the resistance of the resistor if the charge flows in the circuit for 100 seconds? So I've got T is equal to 100 seconds. So I need to find the resistance of the resistor, R. So right then, so resistance is equal to voltage over current. I know I've got a voltage, but it's shared because these two components are in series. That 9 volts will be shared across that and that. However, what I do know is because this is a series circuit, the current flowing through this circuit, I, will be the same. So I is equal to Q over T, charge per unit time. And have I got these? Yes, I have. So Q is equal to 300 divided by time, which is 100, which will give me 3. So I've now got a current of 3 amps. So that current flowing through that circuit is 3 amps. Now, so I've got 3 amps through there. Now, I need to calculate voltage over current. I've got current, I now need a voltage through the actual resistor. So I know I've got 3 amps through there. So voltage then is equal to energy per unit charge. So I'm given energy of 900 joules divided by a charge of 300 coulombs, which will give me 3 volts. So I now know that I've got 3 volts across that and 3 amps flowing through that. So R will equal to V over I, which is equal to 3 divided by 3, which is equal to 1 ohm. So the answer is 1 ohm. Now, moving on to question number 12. A battery of 12 volts supplies a circuit with a 4 ohm resistor and a 2 ohm resistor in parallel. How much charge flows in the main circuit if the battery is switched on for 100 seconds? So again, we need to draw a circuit. So I've got a 12 volt battery, and I've got a 4 ohm resistor. There we go. In parallel with a 2 ohm resistor here. I've got 12 volts. How much charge flows in the main circuit if the battery is switched on for 100 seconds? So time is equal to 100 seconds. So what I do know then is I will have a voltage across here of 12 volts and a voltage across here of 12 volts because it's both in parallel. Now if I know that and I know my resistance, I can work out the current flowing. And if I know my current, then I can calculate my charge, because I will equal V over R and Q is equal to I T. So let's have a look at this then. The current flowing then through this circuit will be, let's have a look. So you've got I is equal to V over R. So V is 12, R is 4. That's going to be equal to 3 amps. So this means then that I will have a charge, okay, well, how much charge flows, so Q will equal to IT, so substituting my numbers in, that will equal to 3 times 100, which will give me 300 coulombs. So how much charge flows in the main circuit? I'm going to take this one as being the main circuit. if it's switched on for 100 seconds, is 300 coulombs. Okay, we can also work out how much charge is flowing through the other part of the circuit if you like, using again I is equal to V over R, which is equal to 12 divided by 2, which is 6 amps. As you can see, you've got, if you look at this, it's half the resistance, so the resistance has gone down, so the current's gone up. In fact, it's doubled, and you see the resistance is half, so that looks alright. As you can imagine, you can kind of guess what's going to happen here then, can't you? So if we've got Q is equal to IT, and that's going to be 6 times 100, which will give me 600 coulombs, so just double that. So you get twice the amount of charge flowing through this part of the circuit as you do that circuit, and that's because it's got half the resistance. So in our hand, so here we've got 300 coulombs. Right. Now, 13. A series circuit is 3 resistors, one 5 ohm, one 4 ohm, and one unknown value. 500 coulombs of charge flows in the circuit for 4 minutes. What is the value of the unknown resistor if the battery has a potential of 23 volts? So you need to know the value R. So I'll call that R3. Okay. So let's just draw a little circuit. There we go. And it's 23 volts. And we've got 3 resistors. We've got R1, which is there, and we'll call that 5 ohms. Oh. There you go. And we've got R2, which is 4 ohms. And you've got R3. We don't know the value of that, and that's what we're trying to find out. So now we do know that we've got 500 coulombs of charge. So on the box, what I need to find out: R3, unknown value. Underline my data. I'm going to grab my data now. So I've grabbed my resistances, my 2 resistances here. I've got charge of Q is equal to 500 coulombs. I've got time is equal to 4 minutes, which is equal to 240 seconds. And I've got potential difference V is equal to 23 volts. So I'm now going to find, well, I need to know, first of all, the current flowing through this circuit. It's a series circuit, so I can find the current flowing through this circuit, I. Then I'm going to know the current flowing through each of these resistors. Okay, I can then kind of work out, if I know what my current is and my volt and my resistance is, I can work out the voltage that's dropped across each of these resistors. If I know my voltage across R1 and my voltage across R2, I can add them together. The difference between 23 volts and that voltage will give me the voltage dropped across this resistor, and then I can calculate the actual resistance. And there's lots of different ways of doing this, but that's what I'm going to do. So I is equal to charge per unit time. So Q is equal to 500, time is equal to 240, and that will give me 2.1 amps. So this, I've got current of 2.1 amps across here. So current flowing through, so the voltage across R1, okay, I'll call that V1, is equal to I times R1, which is going to be equal to 2.1 times 5, which is to be 10.5. So 10.5 volts. Now I've got the voltage across R2, so I'll call that V2, and that's going to be the current times R2, so that's going to be 2.1 times 4, which is going to be 8.4. Now, what this means is then I've got my voltage across R3 is going to be 23 minus 10.5 minus 8.4, which is going to be 18.9, which gives me 23 minus 18.9, which gives me 4.1 volts. So I know across here I've got a voltage of 4.1 volts. So now I need to find R. So R is equal to, resistance is equal to voltage over current. So my voltage is 4.1 divided by my current, which is equal to, well, it's a series circuit, so the current flowing through all these resistors is the same, so it's 2.1. So 4.1 divided by 2.1, and that will equal 1.95. 1.95. Now, ohms. It tells me here, give your answer to one significant figures, so I'll round that up to 2 ohms. See that? There we are. Wow, that was a bit of a tricky one, that one. Nice little puzzle though.